Hi, I'm Steve Jones and I'm going to explain how an electric motor works. Now I've drawn this diagram, it looks rather complicated, but it isn't really that complicated. There are two main elements. The first is this pair of magnets, one with a north here, the other with a south here. These are usually permanent magnets on small motors, but on big motors they are not. The second main element is this coil here. Although I've shown just a single piece of wire, actually it starts here, it goes round and round and round and round and round and then comes out here. So although it looks like one piece of wire, it's actually several hundred turns on a coil, and there may be several coils. Simply how it works. We have two things: a magnetic field going from north to south, represented by these arrows. And if I use my left hand, I can say my first finger is that direction, is the field direction. Now the second thing we have is an electric supply going from plus to minus. So the electric supply goes up this wire through what is a carbon brush. This is a graphite carbon brush into this that we call a commutator. The commutator is made of two pieces of copper. This copper disc is connected to this side, this copper disc to this side, and these are fixed. So as the coil rotates, this rotates. And as you can imagine, if this rotates half a turn, the insulating part is going to be against the brushes and the electricity will not flow. So what happens when we get a flow of electricity? We've got our field. C stands for current, center finger, current. And if I use my left hand and put it this way, this is called Fleming's left hand rule. And my thumb represents the direction of a force which is exerted on the coil. They must be at right angles. So my first finger is the field going that way. Now the electric current is coming in here. It's going around here, and it's going down there. So, if I put my center finger in the direction of the current, I can see that, in fact, I will get a force down here. And if I do the same this side, because this is going this way, the opposite way, in fact, I'll get a force going upwards. So that's my force there. And what will happen is the coil will rotate in that direction. If I didn't have this device, it would rotate until it was upright and then it would stop. And it would stop because as soon as it went over, again the force would still be going the same way and it would just hold it upright. So what happens is when it reaches the vertical, in fact, these swap over. The current goes the opposite way round. And in fact, it makes sure that the current in this side of the coil, that is, even when this side reaches here, the current is always going that way. And therefore, the force is always making it continue to rotate in a circle. Obviously, this is going to be a very uneven device. It's going to accelerate until it gets vertical. It's going to slow down and then it's going to sweep round quickly, slow down again when it's vertical. So what normally happens, we have at least 3 and very often 6, 9 or 12 separate coils, each put at a different angle with separate connections on this side. This makes a very smooth electric motor where 3 or 4 coils are working at once. So this is very simply how an electric motor works.